Hello my dear students, let us continue our discussion of the chapter indefinite integration, and in this module we are seeing integrals of the form a e raised to x plus b upon c e raised to x plus d having an exponential function in the integral. Let us see an example. It says evaluate the integral 4 e raised to x minus 25 upon 2 e raised to x minus 5 dx. Let us see the first step in the solution, and that's obvious, copying the question. Now, this is of the standard form a e raised to x plus b upon c e raised to x plus d. And the method for this type is that the numerator is a times denominator plus b times derivative of the denominator. So, we are going to write 4 e raised to x minus 25 is a into denominator. So, that is a into 2 e raised to x minus 5 plus b into derivative of 2 e raised to x minus 5. Nothing to simplify on the left hand side, so we keep that as it is. 4 e raised to x minus 25 is a into 2 e raised to x minus 5 plus b into derivative of 2 e raised to x minus 5 is only 2 e raised to x, because derivative of minus 5 is 0. So let's say that. Okay. Now my dear students, there are certain terms in e raised to x on the right hand side and left hand side. Let us collect the like terms on the right hand side together. So 4 e raised to x minus 25 can be written as equal to 2a plus 2b into e raised to x, and you have one term which is the constant term, that is minus 5a. Is that okay? Now you have certain terms on the left hand side, certain on the right hand side. The simplest way to find a and b is equate the constant to the on the left to the constant on the right. That is minus 5a is minus 25. Constant on the left is minus 25. Constant on the right is minus 5a. So these two can be equated. So we have minus 5a is minus 25, or we can conclude that a is 5. Now if I compare the e raised to x terms, we can say that 2a plus 2b is equal to 4. So can I say 2a plus 2b is 4? Out of which we already know the value of a. So we can say that 2 into 5 plus 2b is equal to 4. That is 2b is minus 6 or b is minus 3. Now we have got the values of a and b. So we can write 4 e raised to x minus 25 is equal to a times. A means 5. So 5 times 2 e raised to x minus 5 plus b times. So b times means minus 3 times 2 e raised to x. Students, you can also verify. On the right hand side, if I open the brackets, I'll get 10 e raised to x minus 6 e raised to x, which is 4 e raised to x. And likewise minus 25, which is also there on the left hand side. Now my dear students, instead of the numerator, we are going to write this in the integral. So our integral will have, instead of 4 e raised to x minus 25, what should I write? I should write 5 times 2 e raised to x minus 5 minus 3 times 2 e raised to x upon 2 e raised to x minus of 5 dx. Now, in the next step, it is obvious that we are going to separate. So what we'll get is only a 5 in the first term. So what we'll have is integral is equal to 5 minus of 3 into 2 e raised to x upon 2 e raised to x minus 5 dx. So let us separate as two different integrals to get I is equal to 5 integral dx minus of 3 times integral 2 e raised to x upon 2 e raised to x minus 5 dx. Now, integral of 1 dx, nothing but x. So let us write that as 5x minus 3 times. Now my dear students, you are well aware that this integral is of the form f dash x upon f of x. So we'll write here minus 3 into log mod of 2 e raised to x minus 5 plus c. And that's your final answer. My dear students, we will see how to solve these sums using the entrance shortcut in the next module. That's all we have in this module. Thank you very much.